So we've been doing composition, and first of all we added and subtracted, and then we multiplied and divided, and oh yeah, one day we did the little chart game, like where we found the answers. That was kind of fun. We liked that. So today what we're going to do is we're going to try to find out when something is an inverse. And so not mathematically, but what would, if you had to tell me what an inverse of something is, what would you call that? The opposite maybe, right? So the inverse of short would be tall, right? So in math, we're going to define an inverse when you can reflect it over the line y equals x. And so for those of you like not thinking, the line y over x looks like this. It's like a straight line through the origin. And so what that really means in big fat tons of words after all of this explaining is if I'm going to reflect it across, it means I'm just going to switch the position of the x and the y. So for instance, if I'm given a set of ordered pairs like this, to find the inverse, I'm just going to switch the x and the y. Don't hurt yourself doing this, but we just switch the order. So this is the inverse set of the ordered pairs of this. You do the same thing on the next one. And notice, even though the 5 and 5, it's the same thing, you still have to include it in your set, right? Because that would be the reverse. It would be the same number, and it still has to get included in the set. So if I'm given this line right here, and I just took these points straight off the line, that's where they came from. If I want to find the inverse, first of all, if you notice the dotted line is the line y equals x. That's the line it's already put in there for you. So if I take this set of ordered pairs, if I just flip them, and then graph them, the orange set. So this is what the line looks like. So the orange line is the black line reflected across y equals x. It's the inverse. So if I want the equation of the inverse, I have to get it algebraically. Well, we could do the slope and the y-intercept and all that. But if I start with this, and this is the black line, if I start with that, so f of x, that's the same as y, correct? They're the same thing. So to solve the equation, I'm going to go ahead and flip the x and the y. And so when I do that, this is what I have. So the first thing I do is I flip the x and the y. And the next thing I need to do is just solve for y. So I'm going to subtract 4. and then I want to solve for y. So I'm going to divide by 2. So this is the equation of the inverse function. Inverse the x and the y, and then solve for y. Go ahead and graph the next one. Did everybody check their name? Because it's going to be important when I'm taking roll today. Okay, so make sure that yours looks like mine. So the first question is the inverse a function? Thumbs up for yes. Thumbs down for no. Okay, so if you said no, turn to your partner and tell them why. So if you said no and you have a reason, who can share why they think this is not a function? It doesn't pass the vertical line test, so this is not a function. Whoops. It doesn't pass the vertical line test, so it's not a function. All right. So let's solve algebraically for this. So the first step to solve algebraically, what do I have to do? Flip the x and the y. So this is x now, and this is y. Next step, solve for y. So the first thing I want to do is what? Subtract the y. So I'm going to subtract the 8, sorry. How do I get rid of the 2 on the denominator there? That's right. I'm dividing by 2, so the opposite is multiply. So if I multiply this side by 2, what happens here? These cancel, right? So I get 2x minus 16 equals y. And that is your inverse equation. Once the y is by itself, you win. So I'm going to switch the x and the y and solve for y. First step, add the 5 every time. Either add or subtract first. The next step I just want to get rid of the 3. Only the 3. I'm dividing. What's the opposite of division? So I'm going to multiply both sides by 3. And when I do that, what happens to the 3's on the right-hand side? They cancel, and that leaves me with 2y, right? I'm going to distribute the 3 on this side. And then to finish the problem off, what do? Divide by 2. if I look at both of these guys, if I look at both of them, when I solve, what am I solving for? What is this? Like if I graphed it, what's it going to make? It's going to make a line. And in the first one, is it a positive or a negative slope? Positive. The 2 is positive. And what does the negative 16 tell you? The y-intercept. So it intercepts all the way down in the negative. What about this one? What's the slope on this one? So it's 3/2, right? And the y-intercept would be 15/2. Okay? So up 3/2 would be our slope. So both of these would be straight lines, and it gives you the y-intercept and the slope. But what's going to change on the next two? There's a squared this time. So first of all, this starts, if I graph this, what would it be? It would be a parabola. That's right. And so on this parabola, the 2, is that a stretch or a compression? Stretch, and the -8, which way does that move it? Moves it down 8. So down 8, and it got taller and skinnier. Okay? So now what I want to do is I want to find the inverse of that. And so we already when we graphed, this started as a parabola, and what happened to the parabola when I found the inverse? It laid down, right? Took the parabola and it laid it on its side. And so that's what's going to happen when I solve now. I'm going to take this parabola. When I find the inverse, it's going to lay on its side now. So I'm going to use the exact same steps. I'm going to switch the x and the y. And just like last time, we're going to solve for y. And you told me the first step was add and subtract. So none of that's going to change. Switch the x and the y. I want to solve for y. So the first thing I'm going to do is add the 8. I'm trying to get the y by itself. So the next step is I'm going to divide by 2. Okay? I want to get rid of the 2. Now, I have to undo the y squared. So what's the inverse operation of a squared? Square root. But before I do that, this is what I want to know. If I have x squared equals 4, what's the answer? So that's what everybody tells me, but what happens if I put a -2 in there? Do I get the same answer? What's -2 times -2, Mr. Pfister? So do I get the same answer? Oh, thank heaven. We're having a little problem with our negative sign over here, but I think we're all straightened out now. So a +2 and a -2 gives me the same answer. And I don't know which one is the right answer. So this time, when I'm undoing the squared, I don't know which one I use to get the answer. So I'm going to have a plus or minus in front of the square root. So I'm going to take the square root, and when I do that, I'm going to put a plus or minus here because I don't know which number I use to get the right answer. So my final answer is going to look like this. So we're going to follow the same steps on the last example. We're going to switch the x and the y, and I'm solving for y. And you told me the first thing I'm going to do is always add or subtract. So I'm going to do that. I'm going to subtract my 9. And the next thing I need to do is I need to get rid of the 4. It's divide by 4. The opposite of divide by 4 is? So if I multiply both sides by 4, these 4's cancel out. So the next thing I'm going to do is divide by 3. But before I do that, I think some of you might have the question, why didn't I distribute this? Why didn't I distribute? The parentheses and the exponent, and so it's protected, and you can't distribute there. So you have to just get rid of that 3/4. So once I do that, now I'm going to divide by 3. And I have to do the inverse of the squared, which is the square root. And what did we say goes in front of the square root? Plus or minus here. So that leaves me with y minus 1. Is the y by itself yet? What do I have to do to get the y by itself? I have to add 1. And so before you add the 1, let's be careful where we put it. So if I move the 1 and I put it behind the square root, what does it look like? What? If I move it behind, what does it look like? If I put it behind, it looks like it's under the square root, right? Do you want it under the square root? I don't. So when I add the 1, it has to go to the front, in front of the plus or minus. And there's your answer.